minutes that went up via email ahead of time. I don't know if anyone's got any comments on any of that. Now would be the time to bring it up.
Nope, seeing no changes, I recommend approval of the meeting minutes.
I'll second that. All in favor?
Aye.
Opposed? All right, the minutes are approved as is. Did you get the names, or do you need me to?
I got the names, but thank you.
All right, then we'll move into general update.
Okay, I actually only have one update, and that's, we had a presentation by staff about how we're gonna handle COVID going forward, making decisions what we're going to use in terms of deciding what mitigations will be used during pandemics. And so I'm just gonna give you a real quick overview. So our pandemic team is district leaders from each division. They monitor the data trends, and I'll talk about that in a minute. They talk about process and procedures in schools who don't understand what they should be doing with respect to COVID procedures, contact them and they solve the problem. They meet 4 days a week. Then we have put together, the superintendent has put together a medical education panel that local medical partners and district administrators meet. They analyze data trends. So they're the ones looking at the CDC data. And then they're looking at the mitigation measures that should be implemented given the matrix they've created for the data. And then they meet as needed to complete the matrix. Complete the matrix. So I just brought a couple of copies, but essentially what they've decided to do is use transmission risk as calculated by the CDC to establish what level we will be operating at. And so at the low level, face coverings are optional. Moderate level face coverings are recommended. Substantial, I've got some of the data here. Substantial face coverings are required indoors while within 3 feet of others. That's where we are right now. And then high face coverings are required indoors. What they have not settled is how long the trend has to change for the level to change. In other words, if we are trending out of substantial down to moderate, how long do we wait before we enact moderate remediation? Now right now they've only got it for masks, but they will be doing the same thing for social distancing, for outdoors, for cafeterias, common space, etc. But anyway, that is, I wanted to give you that. Right now we are considered insubstantial, so face coverings are required indoors while within 3 feet of others. That means the teachers can be in the classroom 3 feet or more away from students if they choose to not wear a mask. Masks are not required on playgrounds, not required in the cafeteria common areas. So that's where we are. And if anybody wants to, I just made a couple of copies of this chart. But anyway, that's really all I have to say. Apart from Kate.
That's regardless of the vaccinated.
That's correct. We have no vaccination protocol.
I'm not sure what's been approved for children anyway.
I think it came out today or yesterday.
Today,
Yeah.
it's approved today, 5 to 11, or something new.
Thank you for that. Moving on to public comment, not seeing any specific members of the public here. I guess we can jump over that and get into the renewable energy sources discussion. I know Steve sent out some information on this particular system. I don't know what's the easiest way to discuss it. And I wasn't really sure of the protocol about trying to contact him before the meeting to figure out how we were going to go about discussing it or what type of material we could present. I know we're not supposed to talk outside the meeting, so how do we get ready for the next meeting? That was kind of.
Well, you send it via email to all the participants.
Okay.
Yeah.
But the way it should be is if somebody has a topic that they'd like to discuss, then they should find a vendor or the information and material and provide a presentation to the rest of the committee and share that. You can share it through Julie as your point of contact with emails.
I got some. Monday, we had a meeting at Florida Southwest up in Tampa. and some friends of mine from DC showed me some information from Ashburn, where they've increased their energy protocol from 30% to 50%. I'll pass this around. And when this new infrastructure passes, which it will, whether it does this time around, whatever, they're gonna mandate it. So you need to start, everyone needs to start looking at renewable energy sources for these schools, whether it be in building materials, MEP stuff, however you can start, squeezing it out.
I'm not sure the verbiage of, going from 30% to 50%, I mean, in reference to what exactly?
Energy savings. Right now, they're mandating 30% minimum.
Oh, over the base.
Yeah, what's the baseline on that?
Oh, we can get into that part of it. But that started it
Kind of
all.
an important starting point though, I would think.
Yeah.
The base, what's your base?
Yeah, what's space?
It varies from season to season, use to use, it's all in place.
They are pretty particular about K to 12 and public schools. Period. When that bill passes, we're $1 trillion, whatever, a couple trillion. A lot of money's buried in it, just for that.
Well, in 2017, they updated the energy code, for the uniform building code.
Yeah.
So many of those things are probably already in there that we follow, but again, if this is 30% on top of what they already recommend, pretty high.
Ashley's got a printout for it, I think it's like 30 pages, I didn't bring it. For the new updated, specs, what they're looking for. Mostly it's in MEPs.
So we are not gonna have more windows in the schools?
I don't know what their deal is before, but
Well, no, that we always will have to have,
That's what I say, it's kind of
that's requires a certain
incompatible,
amount of.
skylights, you like skylights, right?
No, I don't have, nothing in the roof.
That was a joke.
Did you provide the by school data?
Yeah, Julie, I believe, should have emailed to all of the
Yeah.
members.
I did.
So,
I have extra copies. Would you like one?
no.
Oh.
No, my question is, and I forgot her name, Barbara,
Cindy.
okay. 5, 6, 7 years ago, did that huge energy study, and then we made some significant changes in our energy use as a result of that. I think it would be interesting for the group to know what was done when and what the outcome was, so that we have a baseline knowing what has been done in the district to address energy usage.
Correct. What she did is, and unfortunately, but it was easy picking fruit.
Now, I
Because we hadn't done anything, so the first year it showed substantial savings. After that, the baseline was created and it was pretty much horizontal. Now, building materials change, and of course, we're switching a lot of schools now, one by one, to LED lighting. You'll see a lot of that in our board updates. So our energy efficiency with our magnetic bearing chillers, our roofing insulation has gone up, one per code, but also the materials we're using. Some schools we use reflective materials. Our impact glass on new windows, anti-reflective coatings, so. But I'll get a study of that so that we can issue it to everybody. We'll send it to everyone to look at what we did to gain that energy efficiency, and potentially it may give us a look into what may be able to be done in the future.
That was sort of my thought. I don't know whether it's relevant to this group, but this board is now discussing it at the board table, and I think they would certainly find that useful. Not that I'm supposed to ask you.
In our design of our new schools, architects, anybody, we do a balancing act. And where you get the benefit and the savings could be in the roof, could be in the wall, in the window systems. Obviously, you don't want to put 19, 30 inches of insulation up on a roof. So we try to do a balancing act to get to that LEED certification, an energy certification between our mechanical systems, nominal window, roof insulation, and then we do buy higher performance windows too, so.
Yeah, I mean, as a kind of a case in point, if you look at the page 2 of the energy usage, Ray V. Potterworth, about halfway down, their bill last year was 124,400 rounded off. And then Tortuga Reserve, a little further down the page, was 96.6. Those are essentially the same schools, just 10 years apart. One has LED lighting and magnetic bedding chillers, includes, thermal envelope, and the other does not. So that's about a 30% reduction.
That's what I'm trying to understand, is this data provided doesn't really tell you if you have a thermal energy storage, if you
Yeah,
have chillers, if you have the X unit, I mean, this, the data is just out of, all over the place, unless you start looking into this.
right. It would be interesting to see, I don't know how complicated the task that would be, building square footage next to it. So like, you can compare elementary schools, but, one might be 800 students, the other one might be 1,200. So it's hard to really see apples to apples unless you can, know some of the buildings personally.
Convert to kilowatts per square foot.
Kilowatts per square foot, yeah.
I think the basis of that request was somebody was gonna get in touch with a solar company and they wanted to know what our yearly bills were, so I think that gave you the background.
But,
Yeah. And Stephen has, I presume, has a presentation today, and the guys from Low Environmental need to come in later today. Is it December 1st or next meeting?
January 5th.
January 5th.
And, 30 years, I was in '98, I was with FGC working on a green building project, and you do all the right things, and you just end up getting harder and harder to find those savings. Well, we look at the supply side, and what we have seen in construction over, the last conversation we had about inflation is coming in energy for a number of different reasons, but one of them is Florida passed a hardening infrastructure hardening bill. All the wooden poles are gonna go away, they're gonna be all concrete poles, that's gonna be tremendously expensive, so the energy bills are gonna go up, and so what we need to do is find a way to lock in, whether it's interest rates now or, pricing now, because we expect it to go up.
Right, and they're also burying a lot of the power. It's something silly, like $1.5 trillion they're gonna spend hardening power systems.
They don't like to do that in Florida, it's hard.
Yeah. But they also got Senate permission to raise rates, like 20% a year until they hit the national average. And we're well below the national average right now, so.
Well, the concept, looking at FPL or some others, that's a public corporation. No matter how much money they save or how they reduce the way they get energy, the shareholders are will not allow the dividend to go down or the company to shrink. It's always got to grow. So what you wanna do is somehow separate yourself from that. You still need the grid interactivity, the backup, but the more you have locally, the more resilience you build into the program. So I would hope to schedule something for January or February,
Can we pencil you in for January 5th, for that meeting?
please. And that would be, they have a wide range, they do big solar systems from 700 to 1,000 acres, they do all the permitting, all the, they're not necessarily the builders, they do the financing, all that stuff. National, and it's a
What was the name of the company?
BOW Environmental, Bow Environmental. Okay, their main office is Cape Coral. They work Pennsylvania, Ohio, Michigan, Indiana, New Jersey, working for universities and big school systems.
Yeah, and part of the thought on that is like, you save, you could, by taking off the grid and kind of investing into one of the systems, you save a little bit of money now, but that's gonna grow exponentially as FPL's rates change and yours don't. So it would be a very different metric, 5 years from now.
The only thing is, what we have seen in public buildings that go solar is that after 8-9 years, when the cycle comes to maintain batteries, change batteries and all that, they end giving the solar go, and now you have a very ugly monument of solar panels that is unused, and they are back in the grid, because even when created savings during those first 6, 7, 8 years, there's no money in the budget, in the annual budget for whatever public building it is, to maintain the system for the life that the system needs to be maintained. So far, unless you're talking about the big convention center, most of the small areas for certain schools and all of that we have seen, and it's been abandoned, so.
But everybody realizes that solar doesn't run the building.
It
You
does,
still run off the FPNL grid.
Yeah.
Okay, so what it does is you're selling that energy back to the FPNL at a rate that obviously reduces your electric bill.
so you're basically always connected to FPL
Always.
anyway, so
Unless you
far
get
we haven't seen any really benefit to be on solar because the cost of the infrastructure and the cost of maintenance for it, so.
The only thing that's certain is change. And FPL has 140 some lobbyists, they don't want it to go away, but things will change and
Well, do we all agree that the last thing we want to do is put solar arrays up on building roofs, especially in Southwest Florida?
Agree with that.
So that limits you to a concept that I think one of you guys brought up where you said, well, how about you put over the parking lots? So it would have to be something that would be
They did it at the zoo. The zoo.
16-foot structures.
Naples Zoo did it.
Correct. And then again, it's not running the building, you're
No, no,
basically
no.
just selling energy back to.
It's just an offset.
You're talking two different concepts. One is to be independent from FPL, the second one is to sell back FPL's kilowatt.
Yeah, we'd never have enough area to
Correct.
provide a solar field that would run the building separately, so it would, the concept of every school would always be selling it back to the electrical entity.
So this is the presentation in January will be based on taking one of those buildings and evaluating how many panels will be provided, how many kilowatts we can generate, and then you can compare how much saving you can introduce to this each building.
I think,
That's what you're
Yeah.
proposing.
the one thing, that I learned when I went in 2018 to watch the Falcon Heavy land, I saw the two boosters land about 4 miles in front of me. What used to be is different, it's changing very fast. So we have this way that we've always done it, and structural engineers tell you can hold something down if you need to.
But you were involved in FGCU, they have a large solar array.
The first thing they did is cancel their maintenance contract on that facility.
So they didn't, I thought they had a solar field there.
They did, in the first year, they canceled the maintenance contract,
What happened?
it just got run down.
And why did they do that though?
I'm not certain.
Solar has a minimal return on the investment because it takes 4 times the amount of solar energy to power 1 kilowatt hour. You only have a solar day of about 4.5 hours. So you'd have to power this room, 15 panels, where do you put them? So the problem is becoming, we're collecting the energy, but how do we then process that and make it work for us?
The only person I know that's accomplished that is Elon Musk. If you looked at some of his houses where inside the stud walls are battery cells and the roof panels are actually collectors. So that is a self-sufficient house that runs on, it stores the solar in all the walls throughout the house. So that is independent of the grid system, but that's the only system that I'm aware of that doesn't have their primary
The
being the
problem
grid.
is the batteries only last 7 or 8 years. And then you have to take all your walls apart.
Removable panels, I'm sure.
Yeah, I'm sure.
I'm sure it's gonna be very,
But that's where it becomes less cost effective,
Right.
because you can't store it. Replacing your batteries that regularly gets expensive as well.
Just don't drive an L to the wall to hang your picture.
So does anyone know what I guess the question I would ask when we come with a presentation is, if we were to move forward with some type of solar or arrays at schools over parking lots, what would the anticipated energy savings be to the school district on a typical campus, potentially? Because we're selling that electric back, what might it lower $100,000 a year bill to?
Well, they're telling me that you get savings in the first year. You can have people, you have companies that do the financing, so the money doesn't even come from the school system. They just, it's hard to explain how Florida is just the last place that it's really happening. but it should be the first. I flew into Philadelphia and there's a 1 million square foot building with solar covering the whole top of it, 4 or 5 story building.
But
You
they
know,
don't have hurricanes.
They don't have
So-
sunshine like us here.
so
I mean, I see a
Nobody have
benefit.
a roof here.
I see a benefit if we could get an entity that would cover both the installation and the maintenance over it, use our property, and then there's a return on that investment back to the school district for allowing them the area to gain that solar.
yeah, that's exactly what they do in other areas.
We're doing a lab building for FGCU, it's about 120,000 square foot of science labs, research facilities. And they've got their roof covered in solar and it's gonna come online in the next few months. But they're getting about 30% of the building energy out of their roof. And we looked at a number of different systems doing that. And the really appealing ones were the ones that didn't do any roof penetration. It's a ballasted system. I believe they're still trying to get Florida product approvals to be able to put on roofs, and they didn't have that in time, so we had to block them off the list. But the other ways to do it, I guess, is to, presently, similar to like a penthouse, have some structural steel out there, then you kind of create this rail system so that you don't have, hundreds and hundreds of roof penetrations that are what's gonna become a problem. But it's kind of like putting a mechanical penthouse up on there. You have a couple structural steel elements penetrate in a few spots, do it right, and then, kind of infill from there.
And that's, my previous life, coming here was pharmaceutical. Typically, that's how we put all the mechanical equipment, so pharmaceutical manufacturing and labs up on piers, stub-ups. The problem with that is our typical roofs down here, because of the weather, 10 to 15 years. So now we know we got solar panels that their useful life by Clarissa, and in my previous history of talking to people, it's somewhere around 10 years. So now your panels run out, gotta be repaired 10 years, you pull them off and put a new panel in through 2, 3, 4 years later, now you gotta pay somebody to take it all off so you can redo the roof. So it's kind of like you're chasing your tail from a maintenance perspective. That's why my opinion is keep it off the roof. I like that parking lot idea. You just have to put it up high enough so that buses and cars and somebody who makes a wrong turn doesn't take it out. Our buses hit everything. Not all of them, but some. Parents hit everything. So we try to limit the number of light poles we have in a parking lot for that very reason. But that would be the area where I would see if you were gonna do some type of array, have a panel system and it acts like a covered parkway or walkways or something like that. And then if someone's willing to pay for it, we get a percent of the action back to the district. It's cost savings, that'd be great.
Well, yeah, staying on something simple like an aluminum walkway canopy, where if there's a drip, it's not the end of the world. There's easier parts and pieces of the campus, but you just have to do it in the right size and scale. I know with that FGCU field, they try to do the high-tech ones where they kind of follow and track the sun to get optimized. First thing to go was the motors, and then they just basically detach all the motors and fix them in one location. Kind of simplified their system, dropped their maintenance. I think that was one of the headaches, was actually the tracking aspect of it, but once they're fixed, they're much lower maintenance.
And that goes back to the first statement, you start with the first world system and you end with a third world solution, because you don't have the money to maintain, so you fix the panels, and then you have to replace the roof, so you take them out, and at the end of the day, you pay for a Cadillac system, and you don't have the return that you want from that system. And I'm all for alternative energy, but the thing is, as of today, it doesn't seem sustainable for a school district. Because adds a cost, an initial cost and an ongoing maintenance cost to every school. You have very heated board meetings discussing every penny, and on top of that, you add a solar thing. Yet it comes beautiful in the numbers here, that when you add millions and millions of dollars in school and in maintenance and technology every year, and then replacement, and I don't see it unless there's a company that can offer, they take care of everything and rent the space, or something like that.
They do. There's a lot of, all the oil and gas companies are trying to get into that, to do financing for big projects. There having to change their models pretty quickly.
One thing is that I've noticed with, that each solar panels provide about 8.5 watts per panel. Look at your kilowatt usage, you require a tremendous amount of square footage. But I like the idea of, just provide as much as we can within the space we have, and just put that kilowatt back into the system that we have, so we can at least get some.
The problem is the bigger issue is the ROI on anything solar is 20 to 22 years. I mean, you go to Department of Energy websites, right there, first page. So people putting the nonsense in their roofs in these houses, it's almost laughable because all they're doing is taking $150 to $200 of saving and flipping it over to a panel company. All you do is washing off the bill and paying somebody else. And they're claiming they're getting the savings, but we've done tracking on this for the last 22 years. And it comes out to a 20 to 22 year return of investment.
Yeah, we haven't really had inflation over the last 20 years.
Yeah, the energy spike we're about to see is gonna change those math equations.
Turn upside down.
Yeah, so if you can lock in an interest rate now for something, the next 20 years, that the interest rates and the cost will continue to go up, whereas the deal that you make, be a level playing field. So even if these numbers didn't change a lot over the next 20 years, it could stop them from going up tremendously.
All right, my turn. Scott, to your point, yes, there is technology that exists that converts solar into thermal into energy. It's called a compact solar mag drive. It's basically fits in 2 connexes, uses solar to convert to the battery to store, to drive the mag drive to create electricity. It's meant for more or less daytime usage. Anything below 230,000 kilowatt hours per month would run the system. Would not require any kind of FP&L maintenance because it's downstream with them, so it's its own power plant. And if there were extra power at the end of the month, it could be sold back to FP&L for a premium, or kept on site. These things can be leased, purchased, whatever, but there is no more power bill. Your power plant is sitting in a connex on the yard at the school. The larger projects have what's called an LN2G, which is a liquid natural gas. It's basically a Stirling cycle engine that produces the power using solar as a thermal. It will be a metered service. It comes from a PPA, so there's no charge to the school. Requires about 5,000 square feet-ish to install. You can almost book in, like he was saying, guarantee your rate for the period of time you have it. During the PPA, it's about a savings of 10%. After 7 years, it's 30 to 40. So as opposed to not even costing you money to install, it now becomes a cost savings within 7 years.
So 2 Connex trailers with this system would be enough?
On the mag drive system, yes, typically it doesn't require a whole lot of space, because all it is a giant inverter, batteries, and a mag drive storage. The LN2G, it is a pretty big power plant. But again, these are both self-sustaining, non-FP&L, and they are actually truly green.
Okay, so the question would be, would that power a whole facility?
Yes, it would. The LN2G would be more than you could ever burn. You'd be sending it back to FP&L anyway. Most of your schools here, you only have about 15 that would meet that requirement. All high schools, a couple of middle schools, this building. You're talking initial savings of $343,000 in the first 7 years, $1.6 million for the rest of the term.
Well, I think we'd still want dual power, because nothing
You
is,
still have that.
nothing
You have
is,
FP&L as the backup. So
Right,
if
nothing
anything
would-
were to happen to the system that creates power, then you'd have FP&L as the backup.
but I mean, nothing in life is self-sustaining, nothing is. It may have a good run time, but even my mag chillers break down over time. So, to me, we would still have to be on the grid, the FP&L, to ensure that our schools stay open. Whether there's a lack of solar time, 8 days of an impending storm. But if you have a unit, I like what I heard. If you have a unit that is relatively small in size, that could power a school under most normal business days, with minimal maintenance, that the district didn't have to fork out money up front, but it could be provided by a company, we just lease space and gain the benefits of the energy savings. Sounds like
And
a
there may
win-win
be
if it's.
some ARP money left out there for just that. I know Collier had 80 million allocated for something like this, so I'm sure Lee can get some of that action as well.
And where else locally might you find one of these systems employed?
Not down here. It hasn't made it this far south yet. The only things they've been using for are solar farms out on the west coast and very large power consumers, hospitals, things like that. So the system can be designed smaller to create to meet the needs for a school, a larger school, smaller mid-sized schools. Most of the elementary schools, they don't pull a whole lot, but then again, too, the price for the system would be based on the power supply needed. So a larger school may cost more to build one of these things, but a small school would not cost as much. And it would meet your solar requirements as well, because it only requires a few panels per, as opposed to having all these panels feeding back to FPL, because it's all kept on the site,
So you have PV panels that are charging what?
charging the batteries.
Batteries, and then
On the max
Batteries-
system.
batteries go to inverter?
Batteries go to inverter spends the drive generates electricity, sends it back down to.
Spins what drive? That's where I'm losing the.
The mag drive. It's basically like a Stirling cycle engine, where it uses heat to move the piston. The piston then turns the wheel, which then creates electricity. So
Okay. So
solar
it's a
is,
generator.
it's basically a generator without the term generator, because it's not, there's no combustion, it's not need to be maintained, it's just wheels that turn based on the inverter, powered by the batteries, powered by the solar.
And
So is-
generator provides the power that's used by the facility.
Correct.
So if the grid is down because a hurricane or whatever, your system still works?
Correct.
So you can still power the school,
The schools then will become
Even
also
if you have
a
it 10 days or
shelter or a
the shelter?
refuge point, correct, yeah, refuge,
So you can power the shelter,
correct. But then also you can stop buying generators from
that's to
CW
avoid the
for all your
generator.
new schools.
Why the system?
But at the end of the day, if this is a
that.
generator, it's gonna have to be massive. Because the generator we provided are
But
sheltered.
that's also a diesel power generator.
There's no
This is
battery
not-
tanks
this is not a
in it,
combustion
any
engine.
of that.
No tanks.
Still,
it's-
the motors,
How long?
the windings are big enough to generate that amount of power.
Well, your solar day, you have to be like pitch black, so, you're still getting UV rays, even though there's a cloud cover. You're not getting like the full on, but you can run, 8-10 days without recharging them. Because again, you're still having a solar day, because you can't see the rays, doesn't mean they're coming through. We have to get a pretty severe, dust cover.
What's the initial cost?
For the smaller systems, I don't know. It would be specific to each school, based on their needs, based on, what would be required. But with the larger one, there is no cost. There's a PPA already in place, some government funding for them.
Isn't there some inefficiencies from going from energy from the inverter back to a mechanical device, friction in the bearings, and all that? Isn't there a little bit of loss?
You're talking about.
As opposed to just, as
As
opposed,
opposed to the 30% you're getting from your FPL, this one operates at 85%.
well, I'm just saying, I'm just thinking about the flow of energy through your system. PVs charges the battery.
Correct.
Battery runs a device which
Correct.
makes energy, electricity.
Mhm.
Why not just go directly from the battery to the inverter and send the energy back into your grid, your internal grid, as opposed to having a generator spin?
How do you power it at night?
Well, I don't know.
That's how. So basically,
Batteries,
the
because it's
solar
stored during the
battery will power during the day. But then as you lose your 4.5 hour of solar day, the drive then would kick in and take over it while there's no actual solar activity.
So it's like a hybrid system like you have on a car. That's what it sounds like.
Pretty much, yeah.
What's the lifetime on the stator and stuff like that, bearing assemblies?
They're not, there's no actual component that would grind against it, so I'm pretty sure it's a long term, but I don't have that answer. I'll get it for you though.
And they take care of the
And they do have
replacement.
10-year and 20-year warranties on these, so 10 years right up front, you can buy a 20-year warranty.
They maintain the
Correct.
system, change the batteries.
There's no hassle on Scott.
Sounds too good to be
What is
true.
the
Why,
cost?
why, so
They
if
make
it's that
money.
good, why?
They're making
No, no,
money,
everybody
they're
does.
great, since somebody FPL makes their money. They're charging,
Okay.
now on the
larger
LN,
school,
on the
I know.
LN2G, on the big system now,
Big system.
you still pay a per kilowatt hour of usage. While
That
it's
reduces
less than
cost.
what you're paying now, and then it goes down after the PPA is met. With the With the battery inverter drive system, you buy the product up front, so it's not cheap, I would imagine. It's probably gonna cost some money, but it would pay for itself within the 7-year period, based on the fact you're not paying a power bill anymore.
I don't mean to put you on the spot.
Go ahead.
Over, the closest LNG facility I've seen in this state is on 27 and 70. So transport, how's that handled?
It's not you don't fuel it, it uses nitrogen, again, to move the Stirling cycle engine.
Right.
They used to use helium, but it was too weak, so they started using nitrogen to allow it to stay and have more pressure. So you don't have to bleed it off and replace it every 6 months, 2 years, it stays in there.
Okay.
Because again, it's also in the air we breathe, so.
No, I got that.
Yeah, but no, you're not required to come in and look at nitrogen every couple of days, like you would on a diesel power generator, once it runs down. It's not using nitrogen to actually make the energy, nitrogen is just the gas that allows the motion to happen, to create the energy.
So you say that if it's a 7 years to pay the system,
Mhm.
so you say that a school that spends, I saw here, like $400,000 a
Well, let's start
year.
at the top, Allen Park Elementary School, they pay $113,000 a year
So that means
FPL. So if you were to buy
$4.2 million.
in 7 years-ish, so if you were to buy the system for $3 million, then your ROI is less than 6 years. Because again, you're not paying FPL this $100,000 every year.
Or better yet, find an investor that'll cover all the costs, take a bigger piece of the big.
There's gotta be money out there from this government, and now imagine the celebrity on Southwest Florida, what the first ones to it.
Why the system hasn't made it down to Southwest Florida?
It's not something that would be meant for this type of use, it's a much larger commercial scale. And because no one thought to put it to the school, this one hasn't come down here.
What is the minimum kilowatt?
The minimum,
Yeah, you said you have two systems, one is 200.
you need to have about 230,000 kilowatt hours, because the LN2G actually produces 1 to 3 megawatts. And that would be way too much power
Way too much, I don't see
for any kind of building, like a school size, so.
Well, we would follow the same protocol we do on our central energy plants for air conditioning. We go to our campuses where we have multiple schools.
Yeah.
And we provide a central energy plant only for the electric, if that were the case. But again, I don't know that the district wants to expend their funds on something that's not tried and true. But it would definitely be interesting to see if investors were willing to do it at their risk and reap a good portion of that savings themselves, almost like a dividend. And then we, of course, get some savings from allowing them to sample their product on our school
But
site.
how would the investor get money then if it's not metered service?
So you may offset the cost instead of 7 years, in 14 years, and you share the,
Does
savings
the
with
school then
investor.
pay
Well,
a
they could-
metered rate then to the
That-
investor?
That can always be a negotiated rate based on previous energy consumption for those schools year over year.
Yeah.
So in other words, if they reduce your FPNL energy consumption bill by X%, then they reap from the district a certain amount from that savings.
How long has this been around?
Not too long. I mean, the technology's been around since the 1800s. But the use of solar inverter battery and all that is relatively new over the last 20 years or so.
What's the name of the manufacturer?
Sorry?
Who's the manufacturer?
That's American Independent Power, AIPowerLLC.com is their website.
Okay, where can we find one, we can look at one now?
There's not one down here. I've got a study on one in suburban Georgia, the Atlanta metro, where they're using the solar panels as well as the inverter and the battery to power, looks like 7 individual buildings.
How much real estate do you need?
For the smaller system, you need enough room to park 2 connexes.
You mentioned solar panels, but that's part of like on top of the
On
connex
top of the connexes, on a roof or on a, in a parking lot, wherever you want to put them.
what kind of square footage is that? That's kind of.
It depends on the size of the building, again, this is, I'm kind of the messenger here on this, so I know it, not to sound like an idiot, but it would all depend on a solar study.
But the connexes basically are the
The storage container, yeah.
The battery.
40 foot, yeah.
giant battery.
Yeah,
battery.
it's a battery, and they just park them, wherever. Throw a lock on it, no problem.
Can we get some of this information?
Did you send it back to Jeff?
Yeah, he did, there was an email with basically.
That was at the airport, where they had a couple of buildings being run by 6 or 8 solar panels that were powering the batteries, powering the inverter, powering the magnet, or powering the buildings in turn.
That's the same system.
But we would just do this on a larger scale, because again, it's still gonna create enough electricity for the building based on the annual needs of it.
So basically, the limited number of solar panels are basically a trickle charger that tops off and keeps the batteries inside the connexes maintained. And as long as the sun keeps shining and they're maintained, your nitrogen engine, for lack of a better word.
Different system, but yes.
And you still
I'm still confused on why the technology hasn't made it
Massive, yeah.
to anywhere down here. And I don't mean necessarily
The
south Florida.
relative newness, the size of it, you know, you have to have 0.8 acres to put one of these LN2G plants on it. So who really has that kind of available square footage down here, other than a school? I mean, hospitals aren't pressed for it. They've got grants with it, but again, they're still on the whole solar thing. So they're still buying into the whole narrative where they're basically doing the work for FPL and getting a little, altered rate back from them. Now imagine you just cut all that out of completely, so keep the power for yourself and sell it back to FPL if you have more than you need.
Now, everybody realizes Babcock Ranch, those houses are not run by the solar panel.
The solar, it collects energy.
It's a great selling thing, oh, we're green.
Yeah. But this actually is great because it doesn't require anything outside of the sun to provide energy for all the schools.
Well, they've gotta have a website, they've gotta have a video, it'd be interesting to see what their sales promo is on it. But
Who's
again,
that federal money from?
What, for the PPA?
Mm-hmm.
I don't know. I can find out,
I'd like to know.
but I imagine, there's plenty of grid energy money out there, so.
Oh, I know that.
If you've got this technology that works, they'll give you money to keep it going.
Now you bring one down and set it up.
I would love to.
That's right.
And you can convert an existing campus to the technology
Correct.
without
Again,
any.
all that happens is they
without
would install the solar panels, and then they would put the battery, if you would, on the property, come in downstream of that panel to your MVP, plug into it. It'd be a small, transfer switch,
It'd be just like a generator.
Like a generator would,
Mhm.
and it just plugs right in, and then all of a sudden now your meter rate from FPL goes down because you're not pulling any power from FPL, from the grid, it's all being fed by the on-site power grid. And if anything were to happen to the on-site plant, the FPL grid would pick up the difference, correct, like a generator.
Scott, didn't you get one of those generators in 2008, after Charlie, like in Lehigh maybe?
The county put in 2 or 3 large generators, one at East Lee, South Fort Myers
East
High, and I think, one went to Dunbar, but they grabbed that back and took it to Hertz.
Yeah. Ringland did the East Lee with Fortune Electric, and the manufacturer actually was the GC. So kind of went backward, but what they did is they set up the generator and then power the gymnasium and a kitchen or something like that, so that we had a hurricane shelter.
But it's still based on diesel.
Yeah, and they maintain the unit runs once a week or something like it, it'll start up and run for half an hour. It's all monitored off-site.
You're correct, that's what we do with our generators, our diesel generators. They're only meant to power up a third of the lights, emergency panels, phone systems, and a third of the lights, all exit signs, stairwell lights, and things of that nature. When we plug a shelter in, obviously we increase the size of the generator to run the cooking facility, freezer coolers, and all of the lighting within those, like dining halls or gymnasium areas. So,
But
So,
it's still 500 gallons of diesel to run it for.
5,000.
but here's the deal, we
$5,000.
don't use those except in a storm event,
Yeah.
other than running them every 30 days for half an hour, which is required.
now you
Exercise.
still need the generator on site, because my guess is you don't anchor those panels per ICC 500, because that will cost a gigantic amount of money. So if you have a shelter, my guess is you still need your normal diesel generator, because you can lose the panels, or they have, Well, yeah,
Yeah.
but in order to not need the generator, you need to be able to anchor the panels so you don't lose them in a hurricane. So that would be ICC 500, and that will cost a fortune.
But you're
So-
correct, Clarissa, anywhere that is a designated shelter, the system would not work. Because a shelter is based upon having emergency power, which is diesel generator, if power goes out. So if it's a cloudy day and the battery cells deplete in this system, you would have to have a backup generator to replenish that
So you
system,
still
assuming
need
after
to
you have
have
that.
all of that,
No, but close.
you still need to have it in case of you lose the panel.
I mean, if you have a hurricane and lose panels, that's probably a bigger problem to have than just not having a sunny day. But with the LN2G, because that's required panels, it would still act as a power generation source. So you still have your, no need for the diesel generator, because you're already producing power.
How is it producing power if the sun isn't out?
Because it's not solar power. The larger system is all, again, the nitrogen power. So the solar only acts as a heating element to create the 100-degree difference that it needs in order for the drive to work.
But that's the one that you need almost an acre of
Correct,
land.
that's the power
To be able
plant,
to-
so, your larger schools and middle schools would then qualify for this, because again, they would have the on-site power generation, just like you would if you had a generator. But if you have a massive hurricane and your generator's out of fuel, how do you fuel it back up? And you can't get a truck in there, it's just a very.
Well, no, but you still, your generators already have fuel for 72 hours.
Shelter
For
requires
So-
3 days,
so
so.
7 days.
Well,
For in case of a shelter situation. So then,
We provide fuel for 7 days and the trucks on standby.
If they can get a truck, yeah.
Actually, I wanna know.
I mean, if we're talking in theory here, then what if there's a horrible hurricane and, you're flooded out, you can't get a
We
truck
learn
in
a
there.
lot from.
no, the reason I'm
After
asking you is because when you do a school, besides your Florida building code, you also have to comply with your shelters,
Right.
your SREF, and so the system that you're proposing, as appealing as it sounds, is it improved with SREF and
I can find out.
ICC 500 to see, or we still need the double backup? Because it's appealing when you say, well, if I can save the generator, the tanks, and everything that I need, that I have to put there to cover the shelter situation by SREF, if I can save all of that, now the cost of the system is not that high, but if I still need to have all of that, it's an add-on to the budget of the school. So that's the reason I'm asking, if it's any already deal or has Florida approvals and
Good
has
question.
everything that it needs
I'll
for
find
that.
that out. I've never had that question posed, but it makes sense,
You said the panels on this were on top of the connects, right?
Sometimes, it depends on where you have room and what the design looks like. So, I mean, if the theory is no roof panels and they want to be on top of a walkway or in a parking lot or in a field, I mean, just wherever they want to have them placed.
Drive attention.
But we're not requiring to have 4.5 panels per 1 kilowatt hour of electrical use. So your panel counts cut down exponentially. But to find out if these things are gonna work in the event of a hurricane and the panels blow away, how do we get around that?
You navigate.
If it has 72 hours of energy stored, it works.
No, remember the critical need for a shelter is 8 hours. They wanna pass the 8-hour storm with that.
But would you
Then
wanna
you can
have
get
every
fuel
single
trucks
school
in,
in the
you bring
district?
crews in, insert shelters, debris, whatever.
Yeah.
The problem is not if the wind blow off
Yeah.
your panel, is the object being carried by the wind and
Correct.
slamming against your panel.
Sure.
That's where you're gonna get damage. I'm sure structural walls, panels are anchored.
By state requirements, we can't have any missiles on school site.
Well, you got trees, dumpsters,
I know, I
cars,
can't,
and-
but as much as I'd like to
No
take a
missiles.
chainsaw and cut them all down, maintenance problems, I can't.
I don't like that idea.
But I like them, I like them.
It's there, man, when
But I
I,
have to listen because we're doing a lot of projects in Collier County and we start looking into the solar system. And one of the new projects that I have is the mental health facilities, about 60,000 square feet. And we're looking into some solar safety or some energy saving.
you know what you're paying for a kilowatt hour in Collier County. You're paying
That's
30
my
cents, and some of
maintenance
those
guy,
schools,
I don't know.
you're getting, FPL loves your business right now. And how many schools do you have down there that share a property in the middle of elementary? So it'd be a perfect place to put one of these larger systems, that don't require all these solar panels. power both buildings, and it helps with your chiller issues also, just
Something to look at.
heads up.
So I think probably the county should do it first, and then if it's a good deal, we'll follow it.
Let Naples do it from us.
I'd like to see it, I think it's interesting, and who knows, let's see if it could be a potential.
It was really more
Trip to
the
Georgia?
government complex, so that whole complex there, that's pretty built up.
That's kind of what it's designed for, is larger scale, again, because, you know, 4 megawatt, that's a lot of power. Your schools aren't even pulling that annually, and this thing produces it, in a monthly cycle, so it's, nothing down here is really that big, other than like a high rise or a hospital or a large refrigerator warehouse.
The downtown campus is just, it's a thousand square foot. That's something to look into. So this is the presentation in January? The guys coming down.
It's a different kind, but see, ours will work in conjunction with his, because again, they provide the solar panels, they'd probably be the experts on anchoring and what the ICC 500 requires and what ASHRAE requires, but that's more what they would do. This is more of the technology that produces the power based off the solar panel.
Basically, it takes the solar power and amplifies it.
Correct.
Generator without diesel.
So you need less panels.
You need many less panels.
It'd be worthwhile to find
Because
out
all
what
the
that
panel
ratio
does,
is.
all the panel does is collect energy and store it in a battery, and then the battery gets worn down. So nothing is powering the battery. So now if the energy were to power something, it created the power, the battery then is reserved for nighttime use or, off solar peak hours.
So what are the chances of getting a small version to see it work?
Based on the size, we'd have to go to it more than likely. These things that come in shipping containers, so,
That little one you got on the website, how many KVA is that?
I don't know, I'll find out.
Could you?
I mean,
Why you
it'd be
can't just trailer one down here and hook it up?
We've got many high schools with sports lights, eat a ton of energy when they're Friday night football, and the associated concession building. It would be interesting to see a prototype put
That's
there
right.
that would power the sports lights, the concession building.
It powers the whole thing, man. It's
Well, just say like 20 or 30 KVA, something small, you could trailer down there.
possibly,
3-phase?
yeah, it's off quick, but you can convert signal if you need to though.
That would be the way to go, to
Maybe
try
the
it, to see if it works.
I would ask, but yeah, I mean,
Yeah, I always need that test case.
Right.
I mean, the only reason, I think it's important to see it in action on a smaller scale. But typically, and I had an LLC one time in my life too, any company that's got an LLC, limited liability corporation, tells me they're startup, they're fledgling, something that if it was a Tesla concept,
but
it's
you.
usually bought up by General Electric, Elon Musk is gonna buy it up, somebody's gonna buy it up, Bill Gates. So it sounds like it's still a fledgling concept and company, and we would have to, like you mentioned, a hospital. I'd love to see a hospital running on this and how long they've been running on it, and how many times did you have to kick the normal FP&O power back on because you had a failure, and how many years has it been running? How many times does someone have to come in and change the batteries?
Like, see a case study, one of the, what
It
it
would probably be easier to go to Atlanta than to get one here.
Yeah, no, but
Yeah,
I'm wondering, I was wondering about the list of clients on the website.
Yeah.
And see one of those major clients, if there's any case studies, that really
Yeah, if
proves
we
how
can
the
wait
system
until,
works. It's a big investment.
next spring, my house will have one in the garage. I'm gonna be able to be power free on my house.
Are you serious? Or
You must have a really big house.
Yeah, I made a deal, I'm like, look, if I'm gonna present your product to the school board, I'm gonna need to get one of these for my house. And they make a very small scaled down version, it fits smaller than would a regular ATS switch. Small panels go in the garage, tap in right behind your 125 unit panel, 7, 10 panels on the roof. More than enough power.
Go back and tell your folks that we're gonna listen and push it forward, send some more out.
Yeah, just send some down there.
How much cost to do that? What's the cost?
What to do that?
Yeah,
On a house like that, probably $30,000 to
$30,000.
regular consumer, yeah.
and the payback is how long?
Well, if your bill is $300 a month on average, maybe you're talking what, 5 years?
Is that technology available now for houses?
Yeah.
Nice generators about there.
But everyone still, like us and still, we're still stuck on the old ways of how things have always worked, I mean, we've always had a diesel power generator that we could count on, even though we had to spend, 30 minutes a month powering it up, and GW comes in, we pay them a premium to come check everything out. We're just used to this is how it works. The idea that things are changing, we have to accept that, it's hard. So the average person would go and spend 40 grand for a Kohler generator that they could get, 8 kW out of, or 12 kW, park it in their yard, because they know that, okay, well, that works. I plug in a natural gas line, or pour some diesel in it, and it's gonna work. And so the whole idea that now there's one actually in the house doing the same thing, just using solar instead of diesel, it's a hard thing to understand and to appreciate.
And there's no exhaust or anything like that,
Because
right?
it's not a combustion engine.
Yeah.
No,
What about
it's
that?
basically, it's a large watch turning gears based on solar and battery.
So
And
this
then like-
$30,000, well, average my bill, but payback is 10 years. Based on the $250 an average.
I guess 3,
Yeah,
so.
so that's a 10 years, what is the lifetime cycle for this equipment?
Well, we got a 10-year warranty on them, so.
But in every
you
10
can
years,
buy
I
a
gotta spend
20-year
$30,000.
So at 10 years, you gotta replace the batteries and all of that, and you pay for it?
I don't know.
But there's always friction loss. Planck theory proves that every time.
Correct.
So unless this is that,
Good concept.
I built a prototype in Princeton where it's the plutonium running around the racetrack,
Oh, yeah.
splitting the atom. There's gotta be losses somewhere, and you gotta make them up on the front end somehow to keep it a perpetual energy producer.
Well, and on a use point, like, yeah, your electric bill, $250 now, next year it'll be $300. Year
So
after
then
that,
your
it'll be
payback goes down
$350.
exponentially.
No, my question is what happened, because you say 10 years, okay, the average life of the batteries. So 10 years, do I gotta pay another $30,000 to replace all the batteries?
No, the batteries are just part of the components, so I mean, if you're buying the whole system,
Okay.
it's like your car battery only lasts for 3 years. So if you go back to
But does it
Tesla and
cost
say.
$10,000, $30,000?
Go back to the hybrid
But
cars.
you're still paying $100 for your battery.
Well, wait a minute, hybrid cars, when they first came out with them, and the big killer there was everybody wanted it, and then all of a sudden the batteries took a dive, and you got a $13,000 bill on a car you paid $45,000 for, when the Priuses or
Yeah,
whatever
oh,
first
yeah,
came out.
I know that.
So to me, let's take the Tesla, because they're all over the place. How long do the batteries last in that car before they gotta be changed out? And what's the cost of that change out?
Well, then what's the technology difference 10 years from now? Like if you have a system, like look at 10 years ago, what it was compared to now. Would
I
it
would
even
love
be
to see
worth
a case
replacing
study.
the batteries or getting a new system?
I would love to see a case study. I would love to see what happened with a company that invested $10-15 million in the system 10 years later. Did they have to invest another $10-15 million, or it kept working another 10 years? And now it's very appealing that if it work only 10 years, and in 10 years I have to replace the whole thing, it's not appealing anymore.
But
Because I
that's
just finished
for your-
paying
But
it.
that's for your house, so I mean.
No, that's, my house will not cost $10-15 million, I'm talking about for a big system. So, I think the technology is great for the presentation that you're doing, but, I would love to see a case study, something that says, okay, this company has it, this is investment, this is the maintenance, this is the return, et cetera, to see if it's worth it,
So-
because it's a big piece of real estate,
Then it sounded
big
more like
investment.
the interest is more in the LN2G product. That the mag drive, the one that's kind of geared more towards smaller energy production would not be, I guess, as palatable until they see it in action. Because there's the propensity for batteries wearing out or whatever, but the larger products, you're not paying for that. You're basically letting them put it on the property, you pay them a metered rate every month, so there is no investment up front for you. So if it costs $1,000 to fix it, by you 10 years later, that's still $1,000 you didn't spend on it. Because you didn't buy it for $12 million. It was an idea, we wanted to find some ways to save energy. I guess the idea is here, so. I'll take the arrows, let's go. So I'll find you a case study, think about that.
So, yeah, we were kind of snuck by 5:30, and I'd like to keep the conversation going, anything bring up, and we're gonna force an end to it. No, if you have to leave, leave by all means. Bob turns into a pumpkin at 5:45.
He goes to play music now.
But I did do that, I built the President Verde Oracle Accelerator.
Yeah,
Had the
that's what I
Bob
thought you were
Newman-
talking
And I did the
about.
Bob Newman supercomputer,
But you don't want one of those in school side though.
that's what my head was at. And it's funny, the Von Neumann supercomputer, that was back in the eighties, would fill half this building, and it was one of 8 in the country that, all the big collegiate colleges. And now that data fits in the hand size of your.
I know we were doing debates too, I remember back in the eighties.
So how soon would you be able to provide case study information, do you think?
January.
January? Is that,
No, I mean, to the group, probably a lot sooner than that.
But we don't
If you wanna
know
have
as
a
well.
formal presentation.
December we usually take off.
Yeah, so January will be.
Most committees meet like the third week and they're following
here,
Christmas.
Yeah.
December, wow, we're the first Wednesday.
I'll take that.
That makes no sense. It's always a problem in January because of New Year's. It's never a problem in December.
Right.
But still, we take
January,
December
not
off
December,
anyway.
yeah. Hey, January, it's the Wednesday, so.
Well, he's got till May, that's when hurricane season kicks in, he wants to get his father-in-law to plug that thing in his garage by then, right, so.
No, I closed my house in March, so I've done my part. Father-in-law, I don't know this guy. I mean, literally, we were asked last summer to help introduce the solar thermal to the state. And, there was a big E&P blackout warfare kind of white paper produced by the E&P Task Force on Homeland Security. And this is more or less a way to defend the state against a grid failure or a grid hack like Colonial Pipeline or E&P or anything like that. So, and again, it was geared more towards large scale cities, not so much small stuff where it's just a few buildings. And, when you brought the idea early in the year about renewable energy, I'm like, well, I've talked about it before to somebody else, let me see if we can get it to work on a smaller, granular level.
Interesting. Yeah, I'm open
It
to
is
hearing everything.
interesting, yeah.
All right, real quickly, I guess we'll go around the room for good of the order. And with the realization that we're gonna be trying to talk to Russ's folks on January.
Yes, they'll have something quite specific for some of these schools.
Okay.
We can find what we think is open space and, around school or something like that, and then have actual, sample project.
And can we talk to them offline, forgive the pun, from the group, or is that
As
done?
long as you're not talking about the school meetings. Private business.
There's business for the schools though, so how does that?
Yeah, that's kind of what I was trying to figure out.
Yeah,
Apply to
I don't
another
think
company.
so.
Yeah, okay, so.
I think technically he was supposed to communicate with Julia and then she can kind of pass it on. I think that.
But what if it's his company wanted to communicate with that company?
Yeah.
And leave them out of it?
Yeah, your two companies can communicate all day long, but at the end of the day, anything that either of you have should really be funneled through Julia, so it can be funneled to all of the committee members.
Right? Okay.
Well, we have competing but still parallel ideas here, and both of them would require the other, so it'd be nice to have for the next presentation, at least some sort of a collaborative talk before that.
These guys.
So that we can answer to the questions like you and Alan.
Now, on top of that, I wanna communicate with you about other projects, so.
Well, you have to do that in a meeting, or you have to send Julia an email with what your question is, and then she can send that question to everybody with the answer.
All right, Darren, anything else? Good of the order?
I'm good.
Good, well wrapped up, Russ?
Cross your fingers for infrastructure, we can keep this boom going for a couple more years.
Absolutely.
Good.
You?
Good.
There's one thing I was thinking about, just kind of thinking out loud, and I'll make this real brief. We kind of, like you said, we picked the low hanging fruit of changing out to LED. There is the kind of the next level of like smart classrooms. I want to kind of study with the cost effectiveness of that. There's systems where instead of every light fixture having its own MC cable and conduit all running around above ceiling, you basically put one box above the door. And then everything from there is low voltage. So you don't pay for any conduit, it's all just cabling to all the light fixtures. And then at the same time, the light fixtures would have photo cells in each of them, or in each row or bay, in relation to the closeness of the window, so that it could start dimming your lights automatically, making sure that you had 40-foot candles at the desk level, But if your light only has to be 40% on, you're using 40% of electricity. So if that one's close to the window, it's 20%, that one's 40, that one's 60, you know, exponentially kind of lowers the light levels, assuming that, you know, you can all have the foot candles you need at desk level. And some of the cost investment of not having to install 100 boxes of conduit and all that stuff above ceiling, you just run your power down the hallways and then feed these little brain boxes off of the hallways, can kind of offset the cost of the actual technology itself. So that's just kind of one of those things I've been thinking about. It's been around for a long time, but it's been getting more and more efficient for the last 7-8 years or so.
It's getting less expensive. It's getting less expensive.
Exactly. So I mean, it's gone past the test study phase to where it's actually effective, and you know, I might wanna try to put something on future agenda to maybe talk about that. So I mean, it's like the next level of reducing consumption. But anyway, that's thinking out loud. So with that, we got a vote for adjournment?
Sure. Make a motion.
Darren makes a motion, the second.
Second.
Mr. Hood, thank you all very much, and we will see you in January.
Happy New Year.
Hopefully